Hi everyone, welcome back again. Actually, we have started atomic structure and stopped in between. We have kept a revision session and we are continuing again. But now we are not going to talk about atomic structure. But don't worry, we are again going to continue it. For a few days, let us discuss about the things which we try to by heart and try to remember it. Okay? Then fine. Today we are going to discuss solid H2O2, gaseous H2O2. Their bond lengths, bond angles, dihedral angles. Means if you want to remember their values, if you long time practice it, they will be remembered. But in exam, once if we confuse, we cannot remember. We cannot again regain that. Means we are not going to remember it perfectly. Means 145.8, 147.5. These are the bond lengths you remember. While you are reading, you say that solid H2O2 has 145.8, gaseous H2O2 has 147.5. Yes, I remembered. But if we forgot, how we should not forgot it? We have to remember the reason. If we remember the reason, we won't be confused. If we remember the reason, we can remember the value automatically. Because on reading and reading, we'll automatically remember the value. Just let's start the things. Now, this is H2O2 in solid state. This is H2O2 in gaseous state. Why here hydrogen bonds are there? Why here hydrogen bonds are not there? We know that hydrogen bond is a weak force. Yes, it's one of the weakest force in the chemical bonding. We discuss it. Don't worry. What is the basic thing in a gas? All the molecules move randomly here to here, here to here, here to here, here and there. During the motion, the hydrogen bond force is not enough to hold two molecules together. So, in gaseous H2O2, the hydrogen bond is not enough. The strength of hydrogen bond is not enough to hold the molecules at one place. So, there is no hydrogen bonding between the molecules in gaseous H2. Coming to solid H2O2. We know about solids that all the molecules are packed tightly with less intermolecular spaces. So, while two molecules come together, if they are at enough distance, the attraction between lone pair and one of the hydrogen of the another molecule of H2O2 form hydrogen bonding. Here partial charges arise because due to the attraction. Here the electrons come towards this side. Okay? Now, what happens to this bond length? First we discuss about bond length. These are lone pairs, we know that. Lone pair repulsions greater than lone pair, greater than bond pair. Yes? During this lone pair repulsions. First we will talk about gaseous H2O2, then come to this for better clarity and understanding. Here lone pair repulsions will be there. Yes, because the lone pairs are beside, they will repel. During the repulsion, the lone pair and the bond pair, the lone pairs move farther from each other to attain a stable position. Yes? Fine. They move like this. Means they are like this, right? They move like this. Like this, okay? They move like this, and here lone pair bond pair repulsion. This hydrogen means this hydrogen comes like this due to lone pair bond pair repulsions. So here bond angle decreased when compared to solid H2O2. You see this? Here what we have observed bond angle HOH in solid H2O2 less than greater than bond angle in gaseous H2O2 HOH bond angle. Yes, is this clear? If sometimes we remember the value is like 140, yes, there will be in 140, we don't remember the value after 140. We know that These values will be in the range of 140s. In options they will give 130, 120, 150, 140. Once we got the things, yes, once we got the things, they give that, for example, they say ask that what are the bond lengths of solid H2O2 and gaseous H2O2. I'm giving some options. I'm giving roughly, don't take more serious, 130.8, 132.6, 147.5, 145.8, 136.2, 137.3, 120.5, 122.3. These are some bond angles. Don't say that always like this won't be coming, but after seeing this, once remember the reason. What? Asked. Oh, anything given the bond lengths, no problem. Let's discuss about them. See, here the electrons are not focused on the repulsions. They are focusing upon the attractions. How? Here, due to hydrogen bonding, they have attractions between H and lone pair. Hydrogen atom and lone pair. Yes. So they can't. While there is some attraction, why do they focus on their repulsions? Yes. For example, I kept this magnets like this. What we know, like charges repel, unlike charges attract. What will happen here? They will repel. I did not like this. What I will do? I did not like the repulsion. I'll bring like this magnets. Now what will they do? They attract towards this side. Like this, by the same phenomena, the repulsions decrease and the attraction between these both increase. We don't need to say that will it be more, will it be less. That is not the matter. The repulsions between lone pair and lone pair are decreasing. Yes. So what will happen if low at starting? See here, no repulsion decreasing because there is no attraction. Means like this. It's here it will be like this. Here it will be like this. No magnets kept here. Here no magnets kept. Means like this. They are focusing on the repulsions. Here magnets are kept. They are focusing on the attractions. Here due to this lone pairs and this lone pairs will repel. So they will move farther. To attain a stable position, they will move like this. Here, there are no much repulsions. So they will try to attract. Means bonding means they are coming together, right? They will attract. So, yes, I am having less repulsions. Means I can go much closer to the, means little bit closer to the oxygen atom. And I can, in that position also, it's able to attain a stable position. So they will move. Here they will come closer. Here, due to lone pair repulsions, they will move farther. This is the reason. See, here they are moving farther. So 147.5. Here they are coming closer. 145.8. What you understand here? Bond length in solid H2O2 less than O bond length. Bond length in gaseous H2O2. Here also O bond length. Yes? Is that fine? Hope the things are clear. Now let's come to this question. These are the options. Yes, I know one thing. Bond length in solid H2O2 less than bond length in gaseous H2O2. Now check the options. They asked solid H2O2 and gaseous H2O2 bond lengths respectively. Respectively means we should give in that order only. We should not give bond length in gaseous H2O and solid H2O2. We should say solid and gaseous only. Mind this point. I know that values bond length in solid H2O2 less than bond length in gaseous H2O2. Which options are there? All the options are like that only. See, solid H2O2, gaseous H2O2. Less than. Hey, don't worry. Let's replace it. 147.5. Don't think 8. This is 5. Fine. This is 8. 145.8. 147.5. Now see, all are having less than. And I know one more thing. They will be in 140s. 145.8, 147.5. Once we know these things, We'll read much more times, right? We'll revise the things many times, so we'll get the values. But once by seeing the options, we'll get a feel that yes, this is the right one. Yes, this is the right one. I can understand. We'll get that. We'll get that after reading multiple times. We'll understand that. Yeah, I read this value. I read this value. This is the perfect one. Means the practice also important. But remembering the reason, our work is getting much easier. Are the things clear? Bond angle decreases. Here, due to lombar repulsion, this hydrogen moves. Here, less repulsion, so it can expand. Means like this, it will come like this due to less repulsion, and here, due to more repulsion, it will come this side. Fine. This is the reason of bond angle here. Less repulsion, so they will come like this. Means come closer, and there also they can maintain a stable position. Here, they are having repulsions, so if they go more closer, they won't be in stable position. Bring these two magnets like this, they repel much, so they will get into a more distance. Means this the magnets, if you keep like this, they won't have much repulsion. Same phenomenon. Coming to dihedral angle. For this, I will say simple thing. For solid H2O2, what is the greater, bond length or bond angle? When compared to bond length, bond angle, when compared to gaseous H2O2, what is greater? Bond angle is greater. So remember like this, dihedral angle is not greater. Fine. Dihedral angle is not greater. For this bond angle there, no, that's why we will give dihedral angle. Means just logic, not any special reason. For this bond angle is greater, for this dihedral angle is greater. Just trick to remember. Hope that I said the things so clearly. Once think about it, try to say by on your own to yourself. The things will be very clear. Thank you.